We've seen the theory, we defined our model, we looked at the variational losses, so we have everything to start running a few experiments. So the experiment number 1, we will run like a conventional variational autoencoder. So here we will use our variational loss, not the alternative one. We have here the Lagrange multiplier. So our loss is the mean squared error plus 0.01 times the variational loss that we've defined earlier. We have here our standard deviation values from the network and the mean values from the encoder network. Then we are multiplying the standard deviation by this function rand n like that we've seen before, and we add to the y encoder mean. This is the y variation, and then we apply the model of the decoder to this y variation. Then we have our y predictions. So we'll train our model, and after training we have here our weights, and we have the plots of the encoder and the decoder filter coefficients. We can see here. So after training the program, we have the weights of the autoencoder and the decoder. We have the coefficients in the encoded domain, and then the added noise controlled by the encoder STD network. So here we will also see that we will run our experiment first without the additional noise, and then with added noise. So here we have our training set, and we have our no noise case, and we have here the noise case where we're adding Gaussian noise with unit standard deviation to the encoded signal, and we infer and make some predictions, and then we will also listen to the results. So first is the training set output for the clean encoded signal for batch 0. So remember, we have two audio files. One is the batch 0, another one is the batch 1. So this is the training set output for the clean encoded signal.
Let him who hath understanding reckon the number.
So we see there is a bit noise there, but the noise has some special characteristics. We will discuss more about this a bit later. And now is the training set output for noisy encoded signal for the same file. So we see it's very noisy, but the noise somehow resembles the original audio file. And this also is a characteristic that variational autoencoder, they also have the potential to be used in generative applications. So when we want to generate certain sounds, for example. Here is for the batch 1, so it's another audio file. Then again, for the clean encoded signal,
We shall fight with growing confidence and growing strength in the air. We shall defend.
so we see that there's a bit of noise in the background, and the noise also has these characteristics that it's similar to somehow the speeches of the training set. And now this is the training set output for noisy encoded signal.
We shall fight with growing confidence and growing strength in the air. We shall defend.
So we see that there is a lot of noise. We added noise, but we can still hear the original output. And we see that because we used the variational loss that penalizes, like we discussed before, it penalizes noise, for example. And here we see that we will have the standard deviation closer to 1. Here is the target and the noise predicted signal for batch 0. Here's in the coded domain for batch 1. So those files were what we use for training, but we also have another file for validation, another signal that it's the same files, but I'm just taking it's a long speech, and I'm taking parts of it. So the first one was the ACES high we used with a certain offset, but now we are using no offset. You listen that it sounds a bit different, so it will play the validation signal without and with noise, but we will see that the model is now less robust to noise, as now is the validation, so the model never seen this signal before. And we will also make a test when we will infer pure noise on the input, and there is no audio file or speech, it's just pure noise, and we will see and listen what happens in this case. So here is the case where the verification set, this is the input, so this is not the output of the model, there is no added noise. This is what we are using as an input to the variational autoencoder.
We shall go on to the end. We shall fight in France. We shall fight on the sea.
So this is the classic introduction of ACES high from Iron Maiden. And now we will see the output of the model for the clean encoded signal. We observe that there is a lot of noise, but the noise also has this interesting shape and interesting sounding characteristics. Now we added the noise, so the verification set output for the noisy encoded signal. We almost cannot hear anymore the original, and this is the case when only noise as encoded signal as we are using as an input to the model. So we are feeding this model just with noise, and this is what it sounds like, the output of the model. Here we see the verification, so it's the original and the predicted signal. And you'll notice that we have much less robust to noise, and we see that we don't achieve good results. Just remember again that this is just for learning and studying purposes. We're just using 2 small audio files for training, but we already can have a lot of intuition about variational autoencoder, and also to take a look of some of its characteristics.